In this lesson, we want to be able to say that I can solve systems of linear equations. We are continuing on with what we talked about in the last video, where we solved using graphing, and we also solved using a little bit of substitution. Today, we are going to finish up with the substitution method, and we are also going to talk about the elimination method. Elimination is actually my personal favorite out of the three methods. It is the quickest in my opinion. So we're going to solve this using substitution. Substitution, we want to take one of the values. We want to solve one of the equations for either the x or the y. It does not matter which one. Sometimes it's easier to solve for the x. Sometimes it's easier to solve for the y. It just depends on what you have. We notice with this system of equations that the x has a 1, the y has a negative 1. So it's going to be easier for us to get the x by itself versus getting the y by itself. How we get the x by itself is we add y to both sides, so this would be an x equals to y plus 10. X is by itself, so now we are going to substitute, hence why it's called the substitution method, into the other equation. So we have 5 would be x, but we're going to replace it with the y plus 10 because y plus 10 is the value of the x, plus 10y equals to 20. Let's solve out for y. So we do our distributive property. So we have 5y plus 50 plus 10y equals to 20. Gather like terms. So this would be 15y plus 50 equals to 20. I'm going to bring this up here so that we have, subtract by 50, we will end up with 15y equals to negative 30. Divide by 15, so y is equal to negative 2. That's the y value. Okay, well, let's go ahead and try to figure out what the x value would be with this one. If you want to figure out the x value, just plug it into one of the equations. It's going to be a solution to both, so it does not matter which equation we choose. So we are going to choose, just for the sake of simplicity, let's choose the second equation. Let's choose this one. So we know the y value, so this would be x equals to negative 2 plus 10. Negative 2 plus 10 is 8. So x is 8. So the solution to this system of equation by substitution is 8 comma negative 2. That's our x value, that's our y value. By the way, this is consistent and it is independent, right? Consistent means that it has at least one solution. Independent means that it has exactly one. Dependent would be the example whenever it's more than one solution. Okay, so this is consistent and independent. Here's another example. A father is 3 times as old as his son. In 10 years, their ages will add up to 100 years. How old are both the father and son? Solve by substitution. Okay, so this one, we have a father is 3 times as old as the son. So we're going to say F will be the father, 3 times as old as the son, so 3 times the S, which is the son. After 10 years have passed, they will add to equal to be 100 years old. So what we're going to end up with for our second equation, we're going to say, okay, well, we take the father's age, and let's add 10 years to that. Take the son's age, and let's add 10 years to that. This should add to equal 100 years old. Okay, so with this, we have our system equation. We're going to use substitution. We already have the first equation solved for the father. So let's just put 3 times the son in every spot we see the father. So this would give us, going over here, this would be 3s plus 10 plus s plus 10 equals to 100. In other words, what we have, we're going to have 4s plus 20 equals to 100. Subtract by 20, so this is 4s equals to 80. Divide by 4, so s is equal to 20. So the son is 20 years old. Let's figure out the father's age. For simplicity's sake, let's plug it into the top equation because it's a lot more simple than the bottom equation. So father equals to 3 times 20 So in other words, this would be 60. So right now, the father is 60 years old and the son is 20 years old. Let's solve this one by elimination. So we've talked about substitution. We put it in place of the other one. This one we're going to solve by elimination. The way elimination works is we want to get the x's or the y's to be the same value or their opposite. Okay, we want them to either be the same value or opposites. If they're opposites, we are going to end up adding the equations together. If they are the same exact, we're going to end up subtracting them together. With this one, what I'm going to end up doing is I want to get the x's to be the same. It does not matter which one. But let's get the x's to be the same. The top equation, we have 2x minus by y equals to 9. The bottom equation, we have x plus 3y equals to 1. So let's make the bottom equation to have 2x. Well, if we want 2x, we have to multiply everything by 2. So take this, multiply it by 2. We are going to end up with 2x minus by y equals to 9. And 2x plus 6y equals to 2. Because those are the same x's, the same exact x's, they're both positive, we are going to take the top equation and subtract it by the bottom one. 2x minus 2x, 0. Got rid of the x. We eliminated it, hence why it's called elimination. Negative 1y minus by 6y, so negative 1 minus by 6 is going to be negative 7y. And 9 minus by 2 gives us 7. Got rid of the x, we're just left with y. So now let's go ahead and divide by negative 7, so y is equal to negative 1. That is our y value. Now let's find our x value. The rest of this with the elimination method is just like substitution method. Just plug it into one of the equations. It does not matter which one you plug it into. So let's plug it into the top equation. Does not matter. It should give you the same answer if that's truly your answer. So 2x minus by y is negative 1, equals to 9. Minus the negative is a positive, so 2x plus 1 equals 9. Minus by 1, so 2x equals to 8. Divide by 2, so x is equal to 4. If this is true, you could plug in these numbers, the x into the x value for the second equation, the y into the y value for the second equation, and you should end up with 1. So this would be our solution by solving by elimination. It's a lot quicker than substitution. You don't have to necessarily worry as much about getting the variable by itself. Let's look at this one. Solve by elimination. We have 3x plus 7y equals to 7 and 6x plus 14y equals to 2. With this one, let's do the y values. Let's get the y values to be the same or opposite. It does not matter. So if we want the y values to be the same, one of them is 7, the other is 14. 7 times 2 is 14, so let's multiply the top one by 2. So this one would end up to be 6x plus 14y equals to 14. And 6x plus 14y equals to 2. Wait, those are the same x and y. Let's see what happens. Same exact, so we subtract. This would be 0 plus 0 equals to 12. Wait, 0 does not equal 12, so this would be an example where we have no solution. By the way, if it has no solution, this is inconsistent. Okay, so we could label it as an inconsistent system of equations. No solution. There's no x or y value that would work in this situation. And what this tells you is that the two lines are going to be parallel to each other if you look at the graph. If you look at the graph of this one up here where it had one solution, these two graphs are going to end up crossing at one point. That is why it's a one solution, why it's a consistent and independent. Let's do this one by elimination. Remember, we need the x's or the y's to be the same. We have 3x minus by 9y equals 6 and negative 2x plus 7y equals to 5. Let's get the x's to be the same. The only number that 3 and 2, or the smallest number that 3 and 2 have in common is 6. So let's multiply the top one by 2, the bottom one by 3. This will give us 6x minus by 18y equals to 12. And negative 6x plus 21y equals to 15. The x's are opposites. That's good. If they're the same or opposites, we're good. What we're going to do if they're opposites is we end up adding them together. The same, whether they're both positive or both negative, that's subtraction of the two equations. If they're opposites, we end up adding them together. So we're going to add the bottom equations to the top equation. 6 plus negative 6, 0. Got rid of the x, eliminated it. Negative 18 plus 21. So in other words, 21 minus by 18, which is going to be 3y. And lastly, 12 plus 15 is going to be 27. Divide by 3, so y is going to equal to 9. That's our y value. What we now have to do is just plug it into one of the equations. It does not matter which one. Let's plug it into the bottom equation. We've been plugging it into the top equation a lot, so let's plug it into the bottom. We have negative 2x plus 7 times 9 equals to 5. 7 times 9 is going to end up to be 63 equals to 5. Subtract by 63, so we have negative 2x equals to a negative, so 63 minus by 5, we subtract, this would be a 58, negative 58. Divide by 2, so x is going to be, let's go 58, divide by 2. 2 into 5 is twice, that's 4, subtract 1 remaining, bring down the 8. 2 into 18 is 9 times, so this would end up being 29. So if negative x is 29, positive x would end up to be a negative 29. So our answer to this system of equations would be negative 29, comma 9. Let's do another one. I believe this is our last one. Solve by elimination. We can either get the x's to be the same or opposites, or the y's to be the same or opposites. It does not matter. I'm going to choose to get let's get the y values to be the same. So let's multiply by 2. This means that we have 10x minus by 4y equals to 14. And a negative 10x plus 4y equals to negative 14. Y's and x are just opposites of each other, so let's go ahead and just add them. This is 0 plus 0, 14 minus by 14 is 0. So 0 equals 0, that is true. This one would be any x value, any y value. Any x, y would work. This is a consistent, independent solution. So we can say, with it being consistent and dependent, we can say that there are infinitely many solutions or infinite solutions.